Okay, so now the new Keynesian Phillips curve, and again we're relating inflation to output here. Often, as I said earlier, the Phillips curve relates inflation to employment or unemployment. And the reason why we're calling this Phillips curve is because in the set of models we're looking at, there's only the only factor of production is labor. So people sort of decide how much labor they want to supply. So then there's this output itself is sort of a measure of labor supply or employment, if you like. Okay, so the derivation of this equation is somewhat complicated. So I'm not going to actually go through the whole derivation. I'm just going to give you the intuition for the derivation they provide in the subchapter 7.4 of the Romer textbook. So feel free to take a look there if you'd like to see more details. So the way this is going to work is, suppose only a random fraction of firms can change their prices every day. And firms know that. Firms know that every day there's only a probability they're going to be able to change their prices. All right. So the amount that the firms that can change their prices want to change their prices is going to have to do somehow with output. So the idea is, if firms are very productive today, so output is going to be very high, then they're going to want to raise their prices a lot. And if output today is low relative to steady state, they're going to want to lower their prices a lot if it's a big shock. So that's what's behind this. That's what's behind this kappa yt term. So the larger is the deviation of output from its steady state level, the larger is the inflation. In other words, the amount that firms today would like to raise their prices, the amount the prices go up. Okay, so far so good. That seems fairly intuitive to me. We expect that kappa will be greater than 0. Then how do we explain this term here? Why does inflation today depend upon inflation at time t plus 1? All right, well, it's kind of interesting actually if you think about it. So firms know that tomorrow they may not be able to change their prices. So if they expect that tomorrow there's going to be another positive productivity shock, that means that the firms tomorrow are going to want to raise their prices. So since I can't raise my prices tomorrow, possibly, I'm going to want to also raise my prices today even more than I otherwise would, simply because I won't be able to change my prices tomorrow. Make sense? I think I kind of said everything on the slide. So this is a lot easier than the last one because there's no algebra. Although on the next slide, I believe I do have some algebra. All right, so there's the new Keynesian Phillips curve. I'm just rewriting it so we can see how this algebra works. All right, so what we're going to do is we're going to add negative beta pi t and positive beta pi t on the left-hand side here. That's fine. It's just like adding 0. We're adding something and subtracting the same thing. All right. Then let's do a little manipulation. All right, let's see here exactly what we're going to do. We're going to take this beta pi t term and we're going to put it on the other side. Okay, we're going to take this kappa yt term and the ut pi term and put those on this side. Okay. So then we're going to end up with 1 minus beta times pi t minus kappa yt minus ut pi, and then on the other side we're going to have beta times the expectation of pi t plus 1 minus beta pi t. Right? So then we can divide both sides by beta, and we end up with this expression here, which is interesting. This is the difference between expected inflation tomorrow and inflation today. All right, and there's actually two forces going on here. So you can see there's this term here, which is just a unpredictable shock. We don't have to think about that too much. Of course, if this unpredictable white noise shock is high today, that's going to cause inflation today to be relatively high. So that's why this is subtracted off on both sides. But that's all there is. That's all there is to say about that. Otherwise, we have these two terms. This one here has a positive coefficient, and this one here has a negative coefficient because we expect kappa to be greater than 0 and beta is greater than 0 as well. I guess I didn't say that, but beta is expected to be greater than 0 as well. Okay, so how do we understand that? Well, there's two forces going on here. Okay, so one of the forces is the one we already highlighted, which is that if yt is very high today relative to its steady state level, then it means that inflation today is going to be high relative to its steady state level. Okay, but tomorrow, yt won't be quite as high, right? I mean, especially if there's little persistence in these shocks, then we expect yt is going to revert to its steady state level, in expectation at least. So therefore, we would expect inflation tomorrow to not be as high as inflation today. So that's kind of what's going on with this term here. Okay. So yeah, so firms raise their prices a lot today to take advantage of the boom. There's kind of a missing step there. So since prices are really high today, that means that tomorrow, these firms can't change their prices, right? They set their prices high today. Tomorrow, they can't change their prices. So it means that the price level is going to be relatively high, which means that we don't expect inflation to be as high tomorrow. It's a bit hand-wavy, but I think that's the intuition here. Okay, so there's that force going on. We might call that a price level effect or something like that. In contrast, we might also have inertia. So if there's high inflation today, we might expect there also to be high inflation tomorrow. And it enters through this term beta. So you can see that here, if beta is getting very close to 1, then this is 0. If beta is very close to 0, then this is getting close to infinity. I'm just going to quick pause here. Oops. All right, I confused myself there for a second, but now I've got it. All right, so you notice that on this equation here, beta, each of these terms is divided by beta. So I think the right thing to do here is actually to put beta on the other side. So let's look at this line here. Okay, so suppose that beta is very close to 0. It means that basically people don't think about future inflation when they're setting, when they're thinking about setting prices today, or inflation today doesn't depend upon expectations of inflation. All right, if that's the case, then inflation tomorrow is just going to be like another random draw. All right, and if that's the case, then the higher is inflation today, the closer we think that inflation tomorrow will just be to 0. Okay, so so basically, when beta is close to 1, then basically the difference between tomorrow's inflation and today's is just going to be the same as today's inflation, because we expect it to be 0 tomorrow, or the steady state level tomorrow. Okay, so that's kind of it for this new Keynesian Phillips curve. Oh, I guess I should explain this last sentence I have here. So, you know, there's two forces going on here. So there's one force that says if inflation is high today, we should expect it to be low tomorrow. And why is that? It's because firms raise their prices a lot today. So tomorrow they won't be able to change their prices, so we expect inflation to be lower. The firms that can change their prices either won't raise them as much or will even lower them. Okay, so that's one thing. The second thing is there's some sort of inertia behind inflation, which is driven by this expectation. And, you know, I'll just leave it there. So the question is, which one of these dominates? Which one of these effects dominates? And my reading of the literature is that the inertia effect dominates. So we expect that if inflation is high today, it will continue to be high tomorrow.